Okay. Okay. So let me start. So this is the revision session for the quiz 2. So this is the first quiz you'll be facing for software engineering, right? So I think you have already seen the previous question papers, right? So it will be very similar to that. So you'll be having around 25 questions to be answered, right? And the question mostly will be some kind of scenario based, like there will be a there will be a scenario given, right? So from that, we'll be asking some questions, uh, and the weeks will be it will be from 1 to 8. So you don't have the sixth week. So basically, there are 7 weeks actually. So 1 to 8 week will be there for your syllabus. So what I'll do, I'll quickly revise the weekly content, right? I think previously we haven't have any kind of a live session on the specific theory content because it's quite easy only and understandable. But still, like I'll just go through once, and I'll also try to make you understand what are the focus areas are. So next week also Friday we'll have another session. Okay, but that will be mostly a doubt clearing session. So any having any doubt, anybody will have any doubt, they can come and they can clarify it. Otherwise, it's not required. Like you may skip it. So it's not mandatory that you have to come and join next Friday session. It's just a doubt clarifier, I think. Okay, let me start. So what I'll do now, I'll finish everything, then I'll take the questions. Okay. Okay, so I'll start with week 1. So slide is visible, right?
Yes, sir, it is visible.
Yes. I don't know,
Yeah,
the voice is little low.
okay, it is visible.
Okay, let me connect my speaker. To the sound is coming very low. Okay. Uh, so for week 1, so what are the main things or the focus area of week 1? So we basically learn the SDLC, right? Software Development Life Cycle. So where we discuss different phases of software engineering life cycle, right? The steps you can say. And at the end, we discuss few models, right? So those are the different models we normally follow for developing our software projects. So initially, these are some kind of, you can say, preparing a platform to start with. Then we are having the phases discussed. So there is a requirement phase, right? So in requirement phase, we basically try to separate out our kinds of clients, which can be an external client, internal client, or a software as a client, right? So external client, I am making my software, but it is ordered by someone, some other people, or I'm creating it to be sold to somebody else, right? So internals are normally the people who are internal to my company. So I'm creating a payroll system which will be used by my own employees, right? And client, which is another software. Suppose I create a payment gateway. So any e-commerce will consume my payment gateway. So they will become my client, but it's a client which is a software. Right? Then we have the design and development. In the design, the importance of interface is very important. Okay, please go through this carefully. So it is the very same concept you have taught in programming concepts using Java. So there we have taught that the abstraction means you'll have the interfaces. Uh, so we do not expose the internal details of a program or class. Rather, we give certain interfaces to work with our particular classes, and the implementation details it won't be given to the users, right? So what we do whenever I do a development in a distributed environment, right, where the developers are far apart, right? Like I have an office in India, suppose Delhi location, another is Chennai location, maybe another is US some state, right? Now the main issue is like if each of the developer developing their own module, there is no way to have a detailed communication between them. So I don't have a detailed code what the other people is developing. So how we individually, independently develop our modules, right? Now the thing is we need to assume the interaction with other modules, right, cannot be done immediately because those developers are also developing their own module. They are also not ready. So instead of giving their own modules, what they give us interfaces. So those are having all the function prototypes, right? The return type, the output of the function, input of the function. So that is sufficient for me for testing my own module or understanding how to call the other modules. So that's how it says the interface. Once you publish it, you should not change it because there are other developer who are tightly coupled their own module with it. But you can change the implementation any point of time, right? Keeping the interface same. So that makes the developer can be working in a distributed environment without having knowing the entire code details of others. Then we go for the development phase where we basically write the code. Right. Then we go for the testing. So in testing, basically we to confirm that whatever the requirement given by my clients, I compliance to that, right? So I meet all these requirements which are given by my client. Okay. Then once my software is deployed, right? So people start using it. So then anything developer team or the testing team do, so those things all go into the maintenance phase, right? So suppose people start using my software. Suppose it's a web application. Say it's a kind of a uh, what I say. It's kind of a um, food delivery application. Suppose, right? So it says, okay, whenever I'm using the app on a mobile, it works fine. But whenever I'm trying to use or explore it from any internet browser on my computer, it becomes slow or something, right? So that issue raised by the client, so I need to fix it. Maybe I'll come up with some kind of patch. So those things come under the maintenance. So there are some discussion about the testing. So there is something called as alpha and beta testing. So these are almost part of your final system testing and acceptance testing. It's happened somewhere between these two, mostly part of the acceptance only. So alpha testing normally done, so it is after the full system is working, right? So when the system is tested within the developer environment, right? So the testing team within the developers environment test it, it's alpha testing. But whenever it is deployed on the client side, right? And some selective users, I basically select some users who will be testing it. I'm not giving to everyone to test it. I'll select some user, I'll tell them to test it. But the thing is, it will be tested on the client side. Maintenance I have already talked about. So anything happens after the deployment, change of the code, releasing patch, releasing update. These are all parts of maintenance. Okay. Next we have these models. So usually whenever I start, so I get some requirement, start immediately the coding, right? And then I run our code and find some errors, try to fix it. So that's basically what we normally do whenever we start our programming, writing the first project kind of thing. So this kind of strategies are called as a build and fix kind of a strategy, right? But in a real life scenario, so we have to follow some standard models, right? The first model, which is very traditional model, which called as a waterfall model, which calls a waterfall model, where all the phases happens linearly, right? So first the requirement will happen, after that design will come, then the development will come, then the testing will happen, then there will be a release, then it goes into the deployment. So it is one iteration, everything complete. Now the problem is over here, whenever I'm going for a testing, or maybe if I can get it on the testing, it is fine. But once it is released, now client is not happy with the kind of interfaces I created, or he says this is not meeting my requirements. Actually, what I have asked for, so this is not the same, right? Then again, I have to start from the requirement. I need to refine my requirement. I need to refine my design. So everything has to be from the beginning, right? Which is very costly affair, right? So now in the current scenario, we try to avoid this kind of thing. Rather, we go for some kind of a incremental model. So we try to give every time, every iteration, some deliverable to my user and say, is it okay for you or not? I take their feedback, again go start another iteration. But before we go for a prior incremental, let us see a prototype model. This is also very popular. Although we do not go for a traditional way prototyping, but prototyping is still popular in the way. Uh, the problem of waterfall model, the client gets a first look of the software after the release. Once all the phases are done, then only you'll get the first look of the software. But in prototype model, the idea is I'll give a first look of the software or the product at the initial state only. So how I can do it? I'll make a small model, a prototype. So I'll give it to my user. I'll ask them to see it. If you're happy with this, if you're happy, then only I'll proceed with this. Otherwise, tell me what are the changes you require, and accordingly I'll update my software. Right. So I do refine my requirement by giving the prototype. So I may not be having the correct requirement initially. I have designed some pages or something. I want to check with the user. They find it, they check it, basically find it okay, or maybe finding with uh, some kind of differences. So they'll be telling us, okay, these are the problems. So please refine your requirement, and maybe you can iterate with another prototype or go ahead with the creating your software. But remember, the prototypes, once it is accepted, we basically destroy it whenever the deliverable is given to the clients, right? Spiral model is a incremental model. So the main idea of spiral model is risk reduction. What I do, each iteration I give some amount of things to the client and ask take his feedback. So this is called reducing the risks in every iteration. But today, most of the strategies follows in the industry, those are agile. So these are some kind of agile concept. Please go through. I'm not going for detailing these things because this is just a theory kind of thing mentioned over here. Please go through this. But our focus area from the week one, again, I want to repeat. First is all the phases of SDLC cycle. Check out with the interface and implementation part, type of clients, then the models. In models, read the advantage and disadvantage of each model along with the agile one, right? So that is what we'll do for week 1. Okay, so we'll go to week 2. Okay, so we'll go for the week 2. So what we have in the week 2, it's a requirement gathering and analysis. So requirement gathering and analysis is the first phase of the SDLC. So where the first thing is I need to identify my clients, my users, and I need to ask my user what you want, right? Then I need to write it in a pen and paper way. Like I need to do a proper documentation and I need to get it signed up with the clients. Yes, I want this, right? Okay. So now first we start with the users. So we say there are primary user, secondary and tertiary user. So primary user who will be using the system in a day-to-day basis, right? Secondary user, they are not frequent user of the system. They might be using it very uh like once in a year, once in a month kind of a way. They are not the frequent user. Tertiary user may not at all use the system, but they are some way beneficiaries of the system you have created, right? Okay. Now we go for checking out what are the way we gather our requirements. First is questionnaires. So questionnaires, it's like I'm creating a Google form. I know there are some 10, 20 questions which are fixed questions with some kind of a objective or some kind of a drop down list kind of a thing from where user has to select or write a small text, right? So it's very much fixed standardized questions. But when it is good, whenever I need to get the requirement from a huge number of users. So whenever I'm having a large number of users from which I need to collect the requirement, the best way is to use the technique called as questionnaires. Interviews could be a face-to-face or telephonic one. So I say it's a structured, unstructured, or semi-structured. In structure, I have fixed questions. So I prepared the questions, what I'm going to ask. So I ask the question, take a note. These are the answers. Unstructured questions, I have few fixed questions, right? But again, depends on the user's answer. I may ask some clarification question or some kind of other questions which basically take out more kinds of information out of the users. Semi-structure, I don't prepare any question at all. I just start with the initial question. Then depends on how user gives the answer, I prepare the next question. So purpose of the interview, so it's basically we want to explore certain issues, right? Focus group, although it's look like a interview, it's not an interview because it's not one-to-one kind of a thing. It's kind of a setup like a meeting, right? Where the people will be called from different, presenting different departments or different verticals in your company or in your, or your organization, right? Suppose, or maybe different verticals, like suppose I have to find out what should be the selling cost of a mobile I'm new launching. So I'm not only called the sale manager from the mobile vertical, I'll call from the other vertical as well, right? Who are basically making other electronics good, right? So what we do, basically I try to find out what are the conflict areas, right? So once I understand these are the point of conflicts between the managers, then I try to start reaching some kind of consensus between the managers or the people who are attending the interview. So this is basically for identifying conflict, and initially at the beginning itself I want to resolve the conflicts. Naturalistic observations, right? So this is what, suppose I need to start a business, right? Online business. Suppose I want to create a e-shopping portal to sell clothes, right? So what I do, I go to physical clothes shop and maybe I shadow the manager and check out like what they're doing day by day. Like in a full day, I start to shadow him, check out in the morning what he do. Then so I try to note down the task. Documentations are required when I need to go through some kind of rules, regulations which are given by my government or other organizations which I need to follow. Suppose I want to start with a e-commerce for selling medicines, right? So there are certain rules about selling the medicines. So suppose there are certain medicines you need to take up prescriptions, right? There are other rules as well, right? So you need to go through some medical boards. What are the certifications? What are the rules, regulation, government or state rules, regulation or central's regulations? So these are basically called documentation. So requirement gathering from the documentation. This is important area, understanding the requirement which is functional and non-functional. So functional requirement, whenever I require the requirement is related to some feature. I want some feature, right? But whenever it is something related to the performance, right? Then we call it as a non-functional. So if I say I want a portal for my school, right? Where I'll be able to publish the result for the students and students will be able to download the results. So downloading the results could be a feature which is a functional requirement. But if I say the download should happen within 2 seconds, right? Then it's about the performance, and I'll say it is non-functional. Even if I say the portal should be available 24 by 7, so if it is failing, the recover time should not be more than 1 hour. So anyway, the system crashes, we will be able to up it within 1 hour, right? Then it is also a non-functional. So it is about the performance. Reliability, robustness, these are all parts of non-functional thing because this basically check the qualitative things, right, of the system. So, okay. The SRS portion, just read what are the advantage and disadvantage of the SRS. We don't ask any question from this documentation because normally in industry, each each organization having their own format and it's available like given as a template. You need to just fill it up. So don't go for reading all what are the parts of it and all. Just check out what are the advantages and disadvantages. That's all. Now BDD, behavior driven design. So using which the requirement gathering happen in terms of something called as a user stories, right? So user stories basically having three parts. We mention that what is the type of the user, then what is the action and what is the benefit of out of it. Right? So this is the specific format. Then each user story must follow the smart feature. So what is smart feature? It should be specific, measurable, achievable, relevant, and time boxed. So I'm not going slide by slide. I'm discussing it over here itself. Specific means whenever you ask for certain feature, be specific. So suppose I say I'm having a food delivery system. So I say I'll be able to search for a particular dish. Right. But it will be more specific. I say if I able to search the dish by its name or maybe by its ingredients, right? So I want to make it specific. Then we have something called as a measurable whenever I give a duration attached to it. So if I say there should be a download feature for downloading the results. So if I add the downloading the results within some 2 seconds, so it's a measurable thing. Achievable, if I found some kind of user story I have already written, which cannot be done within a single sprint, right? So each user story should be completed within a single sprint. If I find some user story is cannot be completed or achievable within a single sprint, we try to break it into more than one user stories. So I'll make them smaller user stories, right, to make it achievable. Relevant, each user story brings some value to at least one of the stakeholder of the particular product or particular software system we are making. Time boxed, if the particular user story cannot be completed in the given time, we basically stop building it, right? Again, we refine the entire user story and start it. So these are the things what I have already discussed. For everything, read what are the drawbacks and advantages. So that's all. So what are the main points again? Week 2 content. So we start with identifying the type of user, right? Then the different techniques of collecting the requirements, which starts with questionnaires, then interview, focus group, naturalistics observation, then documentation. Then next we have uh, this SRS part, which I told we only check for the advantage and disadvantages. You don't have to go for the detailed documentation part of it. User story, you have to read it very thoroughly. The smart features are very important. The smart characteristics are very important, and also the advantage and disadvantages. Still, you have any question? Anyone? Shall I go ahead? Okay, I'll go. Okay, I'll go for the third module. So this is software user interfaces. So this is somewhat related to the design and somewhat related to design, in the sense design of the interface, right? It is not the software design, it is design of the interface, and it is also related with the software prototype. So if I say SDLC design and development, this is not that design, it is basically design of the interfaces and also the prototypes. Okay, so some designing. Usability goal of the interfaces. Whenever I'm designing the interfaces, I need to remember what are the usability goals. So I'm not going in very detail of it, just a little bit of it. Effectiveness, right? So you're putting this sign in button everywhere in a fixed way, right? So efficiency. So once I give my first order, I keep my address saved, so that next time whenever I'm placing my order, I don't have to again the address. This makes it more efficient, right? Safety features. So that's basically, if you go to any word editor, right, a text editor, you are having a control Z, because if I do any mistake, I delete something, I can go for a control Z to undo it, right? So that's basically a safety measure you have. Or if you are closing a file, it asks for, do you want to save it, if you are not saving it immediately. Learnability. So once you deliver a software, it should be easy to learn, right? So some softwares which are well acceptable, they are like um, it is very easy to learn actually. So it's basically, you can say it's a some way it is self, it gives you some way to learn it automatically, intuitive way, right? So if it is a very difficult kind of software, then it gives a kind of a widget or other way to understand how to use the software. Memorability say, suppose you used to use a software but haven't used it for a long time. But now again you start using the software, do you have to recall everything or it is easy for you to again start up the software? So usually what we do, we use same kind of icons whenever it's a text editor. So for say we give a floppy disk kind of a thing, right? So that everybody can understand if I get this sign, that means we're saying save. Then there are something called as a user experience goal. Okay. Let us finish with the prototyping first. Right. So prototypings are like storyboarding. So storyboarding, normally we are having the cartoon figure to capture the interactions, right? Which explore what the specifying the prototype. Then paper prototype, we basically draw it on the papers and also show the interaction between the papers, right? Digital mockup, we basically design the interfaces on the using a Photoshop, PowerPoint, or any kind of software. And the final one is the interactive one. Suppose I need to deliver a web app, so I use a normally design all the pages and everything, but actually I don't have a database internally, but I have a database with some dummy kind of a thing, or it is not actually interacting the APIs, but returning uh, some random values or something, but user can explore it, go next, check out the interfaces. Now, design heuristics. Okay. I'll go by this. Again, I'm not going slide by slide. So consistency. So which says, uh, again, right, if you're giving the particular sign in button in a specific page, so all the pages should be having the sign in on the specific place only. So there should be a consistency in the design, right? There should be a consistency in the design. So I should use the same kind of naming this thing, etc. Use familiar metaphors and language, right? So normally I use the same kind of icon, same kind of uh, messages, right? So that if user is used to with one kind of software, it is easy for him to understand other kind of software also. Clean and functional design, so it's easily understandable, so we should not clutter it. Freedom is very important. What is freedom says, um, suppose you want to go for a rail booking or you want to do a flight booking. So suppose you go to IRCTC, so you can see, you can give the date and all, and you can find out what are the trains available, what is the cost. But finally, whenever you want to purchase the ticket, you have to do login. Before that, it do not ask for it. So similarly for flight booking also, you find it, you can explore the flights, their cost, etc. But finally at the time of booking, it asks for you to log in. So that's called the freedom. So there are certain public pages for gathering my information without doing the login. So flexibility. So I give some way to use my software for the novice kind of a software, for the new user of the software and expert users, right? So usually if you look at that, I'm having a menu for all these things, but along with that, there are also shortcut keys. So menus are for the new users, right? But shortcut keys are normally for the expert users. So normally I give both kind of things to my users. Recognition over recalls. That is what I already discussed, that you should use the known icon, known kind of things in your software design. Then feedback, show status. So whenever you are uploading a file, you should keep showing the status. Otherwise, user won't be understanding why the page is not moving, right? Prevent errors. So suppose I want to apply for a leave in my calendar, right? The calendar already shows me these are the date where you are a holiday. So you don't should not apply leave on those dates. So it will block them. Right. Support error recovery. Suppose I make a spelling mistake whenever I'm giving a Google search. It suggests, are you uh, do you want to really search for this? Okay, that is more like a provide help, right? Support error recovery is kind of a uh, let me give more good example. Okay, um, let me find it out. So consistency, consistent layout, like I'll have the specific thing in the specific positions. Okay, so I use the specific names, right? The design should not be cluttered. This is clean design and functional design. Freedom, this IRCTC example I have already told. Flexibility, it could be menu driven and along with the shortcut both. Recognize with recall, you should use always the known icon. The command should be self-explanatory. Like, see if I say copy, cut, MB means move. So it is some way reflect that I what I want to say. So this symbols like it is kind of a mail, so I can identify it is somewhere related with the mails. Show status, I normally give a like a status bar or something so that I can track it out, right? What I'm doing. Prevent error, I have already told, right? So this is an example. Suppose if I want to do a round trip, the return date should be after the like my journey, right? Prevent error, yeah, this auto suggest. I told correct only. Okay, if you write something, so it will suggesting the things. Support recovery, it's basically prompt with a message. Okay, what are the mistake you have done? Provide help. So all applications should have a help feature, right? Which let me know how to use it, or if I'm making some mistake, how to recover from that. Okay, so what are the points we have covered up in week 3? First, we have started with the usability goals, then prototypes, then design heuristics. So these are three things. So you can expect 3 questions from each of these parts. So you have to prepare this properly. Week 4 is very crucial because there are a lot of things from week 4 and you can usually get little more question compared to other weeks in week 4 because you can see there are a lot of things. So software project management basically tells you what are the main activities of a project manager, right? What he should do, he or she should do. First thing about different kind of estimation. So I need to find out what should be the cost, what should be the schedule, like how what should be the duration for completing my software, right? What are the stops required? So there are different kind of estimation. So first let us talk about the estimation. The estimation starts with something called about as a effort estimation. How much effort we want for developing a particular software. So effort is measured as a uh, person month is the unit, right? So if I say 10% month is the effort required for developing my software, that means 10 staff will complete my project within a month. If I have 5 staff, then it will be completed in 2 months, right? Like this. If I have 2 staffs, then it will be completed in 5 months. So this is some way help me to find out the cost, right? Then schedule also, and also staff. So if I know that it is 10% month, right? and each person I need to pay, suppose 50,000 per month. So it is 10 into 50, right? Straightforward, what will be the cost? But this cost entirely on the development cost. It is excluding hardware or any other activity. This is purely the coding cost I'm talking about. Now, similarly, if I assume that my project has to be completed in 2 months, right? So 2 months is the duration, the schedule. Then I'll be needing how many staffs? I'll be needing 5 staff because this is total 10. So this kind of thing I can automatically find out if I can estimate the effort. Then there is a part of risk management which will go in little detail theoretically, and configuration management. So which will just overview it. Now first is estimation. So this is as I told, so it will be like person month way. So 12% month means 4 developers in 3 months, 2 developers 6 months, or one developer 12 months. Depends on what is the duration when my user wants my software. And another thing, since I'm telling it is effort for developing the code, so we need to measure how many lines of code we'll have. And the unit is kilo line, not a single line, right? 1 kilo line means 1,000 lines. So there are two techniques. One is empirical techniques, another is heuristic technique. Empirical is based on the experience of the uh, developers, right, who has worked on the similar kind of project. Heuristic is based on some mathematical model. First, we'll check with the empirical model. First is expert judgment. So I called some expert. So expert is a person, a developer who has already worked with similar kind of project. So he'll be telling this is the kind of effort I have to put for developing this kind of software. But as you can understand, it could be always biased. So that's why we can have a group of experts that can reduce significantly the amount of bias. But another better technique is called as a Delphi technique. What happens? We'll be having number of experts. So they initially won't be talking to each other. Rather, there will be a coordinator who will be giving separately the requirement, right? And each of the expert will be find out individually what is the cost, what is the effort, right? Then all these papers will be collected by the coordinator, and coordinator will show the efforts one by one on the board, and every expert will be giving arguing on it, right? So they'll be putting some reason. Who has created, he'll say it is correct because I have thought of in this way. Other people may be saying no, it is not correct. Then again one round of all the these things will be explored, right? Then again they'll be given with another paper. They will again refine the cost and again come up with the next amount of effort. So after doing certain iteration, what will happen? Everybody converts to a very similar kind of effort estimation, right? So that becomes a final effort. So this is quite a good technique to match to a converse to a single effort by a number of iteration, but it takes a bit time. The much easier way to use a mathematical model, which is a heuristic way. So we are having a very standard COCOMO model. So now there are different version of COCOMO, but what we'll read, it's a standard simple COCOMO over here. So how do I do a COCOMO calculation for effort? The effort is my output. The size is the kilo lines. A and B are two constants. Now these two constants are defined by the type of project you are developing, right? So as per the COCOMO, your project could be of three kinds: organic, semi-detached, or embedded. Organic means the requirement is well understood and you are having a smaller experienced team, right? Semi-detached means your team having a mixed kind of experience and the requirement may not be at the initial stage is not very clear. Embedded is very easy to understand. It should have some hardware integration, right? Now see, If you check on the internet, different organization, different book define them in a very different way. Some people estimate on number of lines, number of people involved, right? But we'll go by this, what is written on the slide, because otherwise it's very difficult, because every site, every organization argue in a different way. So anything comes with the question, we'll go for whatever written on the slide. Now, this value of A and B are fixed. For organic, this is the value of A, this is the value of B. If you are given with the question of this calculation, A and B value will be given. But you might have to find out what kind of project it is by reading the description of the project. Okay. So this is you need to identify, but you don't have to remember A and B value. This will be given in your question. But what you need to find out, you need to find out the effort, which will come as a unit of, in the unit month, sorry, person month. So you might be given directly the LOC, number of line of code, which you need to convert into a kilo line, or maybe we say there are 4 modules, each module having this. You have to add up and find out what are the number of lines. So it's easy only, right? But remember, what the estimate you get, that's called the initial estimate using the first COCOMO, right? So sometimes we ask the initial effort only. So if I don't ask anything, we ask just effort, give the effort you are giving after this calculation. But if we talk about the cost driver, right? If we talk about the cost drivers and we say what is the final estimate, right? Then what you need to do, if this is the initial estimate person month, right? Then whatever the cost drivers you have, you need to multiply everything. That will give you the effort adjustment factor. That has to be multiplied with the initial estimate. That gives you the final estimation. So sometime we keep the drivers. I say there are 4 cost drivers which are having cost like this. Find out the final estimation. So everything has to be multiplied. Then that has to be multiplied with the initial estimate. Or sometime we directly give this is the effort adjustment factor. Find out what is the final estimate, right? So don't forget, it has to be multiplied, okay, not to be added. Project scheduling, it's a quite straightforward thing. I'm not discussing this. If you have any doubt, you can ask me later. Okay, so we are having this project breakdown structure, then activity network, this activity network, then net chart. So I think everybody for project read this part at least. Then we go for the risk management. So we basically say there are 3 kinds of risks: technical risks, project risks, and business risks. So technical risks, it is the technical aspect of the project. Due to developers team insufficient knowledge about the product. Right? But it is not telling about the, okay, let me go for it. So developer developing wrong functions and user interface. So these are basically the technical risks, which is related with the technical part of it normally. Shortcoming in the external component. Also read how to mitigate this. Okay. Project risk about the personal resources or customer based problem. Okay. Schedule slippage, insufficient domain knowledge, personal shortfall. These are the project risks. Business risks are basically what the product I'm making, this will be sellable or not. Right? It is not competitive on the market, this kind of thing. Developer doing created unrelated features. So this slide is very important. Please go through this. It gives you the some clarity like how to identify the kinds of risks. This slide again is an important one. How to calculate or assess the risks, right? So I have identified in my project different kind of risks are there. Like I am having this gold plating risks. Then might be I find out personnel shortfall. But how do I identify that which risk is how much crucial and which should be handled immediately? So there is a way to quantify the risks because risks is somewhat a qualitative things, right? But we can quantify it. How do I quantify it? So basically, I find out what is the probability of that particular risk to happen. So what is the probability that we'll have a shortfall of personnel? So maybe I find out there is a probability that's a 0.1. Right? Then I is what is the impact of the shortfall. So there are four values: one, two, three, four. So four is the highest. If I say the impact of personal shortfall is negligible because always I have some backup people. But again, it could be happen the personnel is working on certain things where not lot of people are available on the market so that I can take it. Then it is four, right? So I need to understand what is the probability of happening it and what is the impact on the project. If you multiply them, that will give you the project risks. So that is a quantitative way. So here, suppose I have given four risks identified, the probabilities and impacts, and this is the assessed risks. Then I basically put them in a decremental order because I always try to mitigate the risks which comes on the top, which is having highest risks factor. This part is very much theory. Please read it. Okay. So what is sprint? Very important. Who do what? Right. What is job of a Scrum team? What is the sprint planning? Who lead it? What is project backlog? Who will be there in which meeting? Right. What are decisions taken in a stand-up call? Daily Scrum meeting? What is sprint review? What is retrospective? So each term is important, but this just theory you need to read it, right? There is no other way. So I'll just tell you what are the key takeaway from this week 4. The first, what we have started with, we started with project effort estimation. So we told that there are two ways to do it. The first way is we called as empirical, so which having this expert judgment, group of expert judgment, and Delphi technique. So in which we basically uh, do the assessment or estimation based on the experience of some expert peoples, right? But heuristic model is basically some mathematical model based, so which is COCOMO. So in COCOMO, we understood how we can categorize our project as a organic, semi organic, uh, or a what was third one? What was the third one? Semi organic and embedded. Sorry. Okay. Then we have learned this gives you the initial cost. Then you'll have the cost drivers to find out the final cost. We understood how to categorize the risks and how to mitigate a specific risks. Then how to quantify the risks, which risk should be handled first. Then there are terms and different phases of the agile process, which you need to go through. Then next we'll go for week 5. Okay, any question till now? Okay, then I'm moving next. Next we go for the design. So this is basically SDLC, that design and development, design part. Okay, this is software design. So for software design, basically, okay, so what is the outcome of the software design? Right. So we come up with the components. They're like modules, individually working units, interfaces, the connections between the interfaces between the components, data structure, and the algorithm to work on. So this is the outcome of a design. For design purpose, we basically takes object oriented way for designing it. Characteristics, there are four characteristics of design: correctness, efficiency, maintainability, and understandable. So it's quite intuitive. I'm not going through this. Modularity. This is very important. So there are two terms we have to know. One is coupling, another is cohesion. Cohesion say a software must be focused on a single objective. Right. So if it is focused on, or it basically works on a single objective, then it is highly cohesive. But if it is not, then it is on low on cohesion. Right. Coupling say the dependability between two modules, or in another way, how much information shared between two modules. Right. You can think about an inheritance between two classes, right? If you change the parent class, that will definitely affect your child class. So the coupling is very high, the dependency is very high, because lot of information shared, because all the public and protected thing, non-private things are shared between your parent and child, right? So that's why how much information shared between two module defines the amount of coupling. If you there are a lot of things are shared, so there are high dependency, we'll say there is a high coupling. So coupling should be always low, because if you have a high coupling, if one module fail, other modules obviously fails. If you want to debug one module, then you have to check other modules. Any change you do in a one module, you have to also change other modules. So you cannot do anything independently inside a module. So that's why our expectation is module, uh, the coupling should be low, but all the or each of the modules should be focused to do a single objective. So that's why the coupling should be high. Sorry, the cohesion should be high, right? So low coupling and high cohesion, that is desirable. But if I give a scenario, suppose I say there are two modules, say one is purchase, another is sell, and they are having this kind of dependency and this kind of things, you need to define the coupling is high or low, cohesion is low and high. This depends on the scenario. Again, higher dependency, higher data share means higher coupling, lower means lower coupling. If you are doing one single thing in a module, then it is a high cohesion. If you are not doing that, low cohesion. Then there are different types of coupling. Data coupling, whenever you are passing some parameter from one, so this is you're sharing the data as a parameter, right? We are calling a function from another module and sharing a data through the parameter. Control coupling, you're sending a flag or some kind of status, depends on I need to call a certain function or activity. It's something like I have a switch case inside a module. I pass a flag, depends on that it do a certain things. Common coupling, they share a global data, right? Share a global data. Content coupling, it's normally happens in Java or any object oriented, where I can use a reference. So I can refer the internal of one class through another module class. Now look into the cohesion. First we are having functional cohesion, different functions in a module to cooperate to complete a single task. So all the modules are basically performing to complete a single task. They are basically all performing to complete a single task, right? Sequential cohesion. So different functional module are basically executed in a sequence, right? But sequence, if I say, remember the things, one point, the output of one module will be used as an input to the next module. This is the key point of a sequential cohesion. The output of one module will be used as a input to the next module. Communicational cohesion. A module said to have communication cohesion if all the functions are related and they basically works on a single data structure or a database, right? Procedural cohesion. The activities of a module related by the sequence, set of functions in the module are executed one after another. See, this is the problem. Procedural and sequential, they look similar, but the distinguishing point is this: the input of, sorry, output of one module used as an input to another module. This is sequential. In procedure also it will be called sequentially, one after another, but that thing is not there. Input output, this pipelining thing. Coincidental is whenever your cohesion is low, means you're putting different functionalities inside the same module, right? So that's a coincidental. This is, I'm not going for object oriented design. You know all what is data, what is encapsulation, what is class object, but please read this. This is important. Next, we'll go for the relationship between the classes. First, we go for associativity between two classes. If one class calls a method from another class, then it calls a associativity between the classes. So here seller calls a method from inventory. So that's so I called that seller and inventory are having an association. Having an association. Composite. If one class or one object contains, right, another objects or set of objects. So which I called as a whole part relationship. If I say a book consists of pages, right? So that means there is a composition relationship between book and pages, right? If I say, uh, if I say, uh, CPU consists of a CU and ALU, right? So these are basically the example of composition. Inheritance, you all know, it is the easier relationship. So I say a football is a ball, right? I say a manager is an employee. So ISA clause gives you a clue that there will be a inheritance relationship. Dependency, whenever you are implementing a interface, why it's a dependency? Because if you change anything on the interface, it will be reflected on your implementation class. Like if you make anything changes on the interface, you must change the same thing on the implemented class also. So that's called a dependency. So whenever I talk about the question in the question that there is an interface and your class implementing it, understand this is about the dependency. This slide is very, very important because we usually give a textual description of a scenario and ask what are the relation between the classes. So these keywords are very important to understand that what kind of relation should be there between my classes, right? Then there is UML. So where we say there are structural models or structural view and dynamic models or dynamic behavioral view. So in structural, there are class diagram which depict my classes and the relationship between the classes, right? So this is the classes and relationship between them. So it could be given like this also, and I ask, okay, what are the relationship? So this is inheritance. So clothes and books are inherited from product. Catalog, this diamond shape say there is a composition, right? So catalog consists of products. So this is the composition. This is the association. Seller is associated with the catalog. Dynamic view or dynamic models, we are having state machines view. So where basically we show how the machine move from one state to another state, right? Then we are having activity view or activity model. So that's basically kind of a flow chart how the activities are performed, right? Interaction view or interaction model is the most important, where basically we are having a sequential diagram, right? Sequential model is an interaction view which shows how the messages exchange between your class objects, right? How the messages means how the interaction happening between your objects. So that is captured between in a sequence diagram. Just look into this. The important part are this activity diagram, interaction diagram, inside which you will only have the sequence diagram, state machine diagram, and structural diagram. We have learned only the class diagrams. So you don't have to do anything else. Just go by the theory here. This part is not required, okay? This very same part. You may skip it for the theory. Okay. Anything still now? Okay, I'll go next then. Quick 7. We go for development. This is quite a easy one actually. So initially we start with the development environment, what are the text editor, what are compiler, interpreter, frameworks, web framework, right? So these are the few things you can easily do. So debugging, we start with. So very important to know the clear difference between this term. Okay, please go through it properly. Then techniques to debug. Logging means I'm putting some printf statement. Suppose I'm getting a wrong answer, I'm not able to understand. Normally what we do, we put some print statement to understand where is my error. Right. Dump and difference, basically we basically take a code dump, right? We basically run it several times and take the code dump and check out what are the difference between the code. So there are certain tools for doing this kind of debugging. Then stepping in debugging. So debugging, that's basically using some kind of debugger, right? So that's provided with all kind of languages. Like for C++, C and C++, there is a GDB, right? For Python also there is a Python debugger. Profiling tools basically checks out which part. It's basically you developed a 10 functions. Now we are finding somewhere it is going slow, right? So you want to check out, do a profiling for X functions, how much time they are taking. So this is another way to find out where the problem inside my code. Now strategies, input manipulation, I changes the inputs, find out how the output is changing or am I getting the proper output or not. Backwards strategy, I find out the failure, the wrong output, find out from where the error got generated, then I trace it back. Right? Forward, I know from where the error occurred, then I go forward. Black box testing is occurred whenever the source code is not available with me. Suppose I am getting the error from some API, so the API code is not there with me. So how do I do it? I have to check the documentation, right? So that's called a black box debugging. PDB is not required for the theory. You may skip this PDB part. Then we are having software matrices. So we talked about, I think, 3 matrices over here. First is cyclomatic complexity. So how complex your code is, right? So how do I know? If I have given it the code, I find out number of decision steps plus 1. Right? But remember, if not only the if else, remember that if you are writing a loop, that is also decision, right? Because you put a condition inside the loop when to break the loop. So be careful about it, okay? Whatever the examples given here and previous question papers, please go through that. Then there is raw matrix, which is based on again line of code. So how many line of code you have written inside your program. Hal state is basically the number of different kind of operations you have done inside your project code and how many times you have done it. So suppose I have done 3 operation N1, N2, N3. And N1 I have done 3 times, N2 I have done 4 times, and N3 I have done 10 times. So do certain calculations on that and find out what should be the complexity of the code. So calculation is not required, but you should know what is it. So there are 3 software matrices. Clean code, please read because this is just a theory. I'm not discussing this. Okay. So what are the takeaway from week 7? First, we start with the development tools. What are the text editor? What are debugger? What are frameworks? What are IDs? What are version control tools? Then we go for the debugging. In debugging, we understand what is error, what is failure, this kind of things. Then what are the debugging techniques? Then we find out what are the debugging strategies. Okay. Then next we go for uh, next we go for the software matrices, right? And at the end we discuss this code smells. In between, okay, so we have discussed it. Finally, we go for the week 8. So week 8 software architecture. So this is bit difficult one. The first part is easy. Find out the type of architecture given a scenario. First is client and server. So normally web applications are client server based, right? We are having a mail applications or any this kind of applications. Then pipe and filter. Suppose in my mobile I'm having a camera app, right? So if I take a picture, it do certain refinement step by step, and finally give a refined picture to me, right? So that's basically pipe and filter. So there are different phases input. So one phase generates some output that will be input to the next phase. Then you are having this MVG architecture. You have read this. I'm not going through again. Peer to peer. So it is against the client server. Like it's each of the node or each of the system act as a server as well as a client. So there is no central server in that way, and there is no central control, right? So there are certain theories. Please go through it. Design patterns are objective of a design pattern to have some standardized way to write the code so that the code smell could be avoided, right? So there is solid principle which should be followed. So we first discuss about the solid principle. Okay. First we go for this single responsibility principle. Each class do a single thing, right? Open close principle. Suppose if I say I have to do something else, instead of extending one class, create another class and inherit another class, right? Then you are having Liskov principle. Okay, I'll do one by one. That will be easy. So first is single responsibility principle. So if I have a single class, I'm doing many a thing. If you can find out there is a class which is having the information about sellers product, it's better to separate into two classes, right? So we are creating seller, inventory, and product, three classes, breaking the single thing. So one class do a single thing. Solid responsibility, a solid close principle. What I say, suppose I have a product, right? A class initially, but due to some new products is coming, I need to add few things in my product class. But it say don't change your existing class, but rather you create a new child class of the product class as a clothing product. Because what is there in the product class, you automatically get it, add whatever is extra. So we don't change the existing classes. So this is the inheritance we do, right? That's a open close principle. So Liskov substitution principle is very similar to, if you can just think about the subtype concept we have done in Java, right? It's very important like that. We'd say that if you have on the left hand side a superclass type, a parent class type, then right hand side we give the object which is initially could be a parent type, but parent type object could be substituted by any of the child object type, right? So that we used to call it as a upcasting, right? We used to say any parent type can refer to its own type object or any child type object, but it cannot refer to any parent type object. So that's why the derived classes should be substituted by the base classes, right? So type could be always of base type, but object could be of child classes. So that it is saying. So what is benefit? What is the benefit? Suppose I have a class shape, and you are having the child classes, right? Rectangle, cube, then circle, right? Now, what you can do, you can create rectangle R for rectangle object. You can create circle C for circle object. So if you have to calculate the area, you need to separately call R dot area, C dot area separately. But if you think, I'll create it as a shape is equal to a object of rectangle. If I have to calculate the area of rectangle, so I can just call S dot area. The S dot area will be the same code, but what I have to do, shape S now points to the circle. So if I'm changing the object, keeping the same base class type, automatically my function get different because of dynamic method dispatcher, right? So that is the concept used in the list scope. So I should always have the parent type to refer my objects. Interface segregation is very wonderful concept. Suppose in your shop, right, you do a home delivery of the product, right? So you are having a class deliverable, so which is having some kind of methods like do packeting, do labeling, add address, this kind of methods. So any delivery is happening, it has to implement all this method written in the deliverable interface. Now today I'm starting with online delivery. So if I'm starting with my online delivery class, that definitely will not have this packaging, labeling kind of features, right? Because I'll be delivering it online, right? But if I say all these deliverable classes must implement the deliverable interface, the problem happens. Although I don't need those method, I need to implement. Interface segregation is telling that in those cases, break it. Maybe you'll have two classes, offline deliverable, online deliverable. So whatever the products you want to deliver online, make it inherit the online deliverable, and the products you want offline deliverable, make it inherit the offline deliverable. So that's a interface segregation. Then dependency inversion. See, so I'm having today a shop, right? So I'm having a small payment system and billing system, right? So where I accept today the payment only by the cash, right? So somebody give me the cash, I type it, do the things. So my seller class is only typed out the cash payment kind of a class. But tomorrow I'm starting with this Google Pay, Paytm, credit card, another system. This all system I'm going to integrate inside my machine. Right. In this case, what will happen? My seller class has to be associated with all these classes, and I have to have the methods to call the corresponding method from each of these classes. But dependency inversion says, why to individually connect to each class? Why not have a parent class, say payment account or something, payable, and make all the new classes connected to it, right? So tomorrow, if I'm having a credit card, just create a class, make it inherit the interface. So if I'm connected to this, basically I can call all the payment methods because these are all inheriting no child classes. Now these solid principles could be achieved whenever I go for implementing the design patterns. So creational patterns are about how do I create my objects, right? So this is like something you need to read. If you haven't read it, like Right now, won't be able to teach you these things. Maybe if you have doubt, write it on the discourse, or maybe a little bit of clarification. I can do it on next Friday whenever I'll take class. So factory design pattern, right? So usually, how do I create an object? The class name, then the object name, new, then particular class name, right? So now, what the factory method says, so suppose I have delivery and I am having different type of courier service which I can call for, right? Now there are deliveries which will go to certain cities. There are certain delivery couriers which will go for international delivery. These are some courier which will be doing it within the cities, right? So now every time I need to find out which kind of delivery it is, and I need to instantiate the particular courier service, right? So that means I should have all else if else if else kind of things, and I need to hard code everything, which is considered as a bad practice. Rather, what we do, basically, what we do, uh, we'll have a create object kind of a method. Now, inside the create object kind of a method, we pass. Suppose I need to make a international delivery, so I pass a parameter k inside create object international delivery. So it go for that particular international delivery class and return you an international delivery object. So just one line I have. So delivery courier, then object, but I don't say it's a new international delivery object. Rather, I say create object. Inside that, I pass my parameter. So if I say in the intercity delivery, so I'll again call create object. So I won't change my hard coding. Rather, I'll pass the parameter. That's a within the city delivery. So it will go for within the city courier and give me return me an object of that. So it reduce the hard coding. That means it makes me much more flexible. Tomorrow, different kind of delivery courier is coming means I'll be able to integrate it. Right. Builders patterns are very easy to identify. So builders patterns are basically suffer from a problem that's called a telescopic parameter. What is that? Inside a class, you are having some mandatory attribute. You need to always pass the value for those. And there are certain optional attributes. The user may pass a value for them or not. So suppose I'm having a book where the mandatory is ISBN number, title and cost. Optional is author, published and description. Now think about a situation. How do I create my constructors? One constructor will be fixed with this first three. That's a mandatory. Now one constructor will be the first three along with author, because some people will be only want to pass the author because this author, published and description is optional. Then there will be again a constructor with ISBN number, title, cost along with published date. Then another constructor will be ISBN, title, cost, description. There will be again another constructor ISBN, title, cost, author and published. So all kinds of combination I have to do. So that results into lot many constructor, which makes my code very clutter and and difficult to understand for the user or the client code who will be creating my object. So that's why, so this is called a telescopic construction problem, right? So that's why we keep a different kind of strategy. So we only create a constructor which will have the mandatory part, but for rest of the optional things, we do it in a different way. So that is like a set method we used to do in a Java. No, similar way, we create some kind of a method through which we do instantiate, not instantiate, initialize this optional attributes. Then we go for the structural. The facade is again very easy to identify. So its facade is some kind of, suppose I have created some packages, right, which will support the drawing. So I'm having a package for selecting colors. So there are different color classes, right? Then there is a package which for selecting different kind of patterns. There are classes to select the pen type. So there are different packages and inside there are different classes. Now client want to draw a circle with red color, right? With a red color. So client has to know all the packages it needs, what are the classes it needs, what are the method it needs, and in which sequence I should invoke those methods. So there should be exact sequence he should know, right? Otherwise he won't be able to draw the circle, right? Facade design pattern say why not give a intermediate class, a facade class, which is like a drawing class, inside which I can give a method draw circle, inside which inside the draw circle method I always already written the code to which package, which class, which method has to be called and which sequence. So user don't have to take the struggle to find out the classes and the sequence. Rather, he will instantiate the facade class and call directly the draw circle method, and it will be reusable also. Adapter also very easy. It's basically format conversion. Suppose I am having a digital smart watch today, which is connected to my mobile phone, right? So in my digital watch, what I do, I can measure my body temperature, which is given in maybe in Fahrenheit. In my mobile, I'm having an application which basically identify the body temperature in Celsius, right? Now the problem is the watch is given in some unit and my mobile application is basically accepting the data in some other unit. So that's why for conversion, I basically put an adapter class in between, which will do this Fahrenheit to Celsius conversion. It's always happens. We see all the things, right? So there are certain gateways who do all the calculation in terms of dollars. But suppose your website basically accept the currency in rupees. So we need to put an adapter class in between so that those interchanges will happen automatically. The conversion happens automatically. Iterator already we have used in Java a lot. So we are having this iterator for array list, linked list, which will have this hash next and next. So it will traverse any kind of data structure, right, in a unique manner. Observer pattern, I don't think he has done it in the thing in the video lecture, so I may skip it. Strategy is sometimes confusing with creational. So remember, creational means creational. Sorry, the factory, right? Because it looks very similar. Only the difference is creational is about I'm having different types of object. How I'll be creating the specific type of object. Strategy say I'm having different way for doing a thing. How do I select a specific way to doing the thing? So if you understand this, it will be very much clear once you read it. Again, I say this factory and strategy sometimes create confusion. Remember, factory is about how do I create object of a specific class. So I am having different type of classes whose object could be created. How do I identify which type of class and how do we initiate an object of it? That is what we do in the factory. And strategy, I'm having different way of doing a thing. So it's a method. It's about I'm having different kinds of method to do a specific thing. Right. Suppose I have to make a delivery. I can do it by a train or I can make a delivery by air. Right. So these are different strategy for delivery. So how do I find out? So which specific delivery I need to take it? So that's basically a strategy design pattern. So that's the week 8. Now, if there is any question, quickly I can take it. Otherwise, you do read it. In between, you can put it on the G space or in the discourse. And again, we'll meet on the next Friday for doubt clearing. Anything?
So we'll be getting the recording of this meet, right?
It is on YouTube, right?
Oh, okay. Because I joined a little late and I couldn't take like
So
I tried
no,
to
it is
take the
not live
YouTube
stream.
link, but I couldn't.
It is not live stream on YouTube.
Hmm.
It is not live stream on YouTube.
It is not.
No, no, sir.
It's showing no in this link.
No, that is not YouTube. It's the net.
Oh, it is not YouTube.
It will get deleted once the session is over.
Oh, is it so? Okay, anyhow, I got the recording. But previously they haven't. I don't know why it is not done then. Okay, I'll share the. I have the recording. I'll share it. I've recorded it.
Okay, sir. Okay,
Okay.
Okay.
sir. Thank you.
Thank
Thank
you.
you.
Thank you. Bye. Bye.
Thanks. Bye.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you.